everyone. This video is going to go through question number 3 from the 2013 AP exam. And so what we have is a table of values for the number of ounces in a cup of coffee over a given interval of time. And so the first thing we're asked is to use the data in the table to approximate the instantaneous rate of change at 3.5. So to do that, we're going to use an average rate of change. So if I'm looking at 3.5, I'm going to take the interval actually between 3 and 4. So we're going to compute here. We're going to say C prime of 3.5 is approximately C of, what did I say, 4 minus C of 3 over 4 minus 3. So C of 4 is 12.8 minus C of 3 is 11.2. And we're going to get 1.6, and our units there would be ounces per minute. And so all we had to do there was approximate that value. And so in this year's exam, they actually gave a point for the value and then a point for the units. Okay, so for part B, they say, is there a time t between the interval 2 and 4 at which C prime of t equals 2? And they're asking you to justify your answer. Now, they're asking us to guarantee that a function has a particular slope. And so that, hopefully you remember, is the MVT. And so MVT, there's a couple conditions that we have to show to be able to use it. So I'm going to make a note over here about the conditions we have to check. So the first one would be, is C differentiable and continuous on a given interval? The second one we would want to check is the average rate of change on the interval from 2 to 4, is that equal, we want to check if the average rate of change over the interval from 2 to 4 is equal to 2. If we have both of those things being true, then the mean value theorem says that we can guarantee that there's a point t where the derivative is equal to 2. So let's go ahead and take a look. So in the problem, they told us that our function c is differentiable. So the good news there, the first thing we can state is that since c is differentiable, it is continuous. So we've met those conditions. The second thing we're going to do is check the average rate of change over the interval from 4 to 2. So I'm going to calculate C of 4 minus C of 2 all over 4 minus 2. Well, going back to the table here, C of 4 was 12.8 minus C of 2 is 8.8. This is looking good. All over 2, so I get 4 over 2 is equal to 2. So this is good. We know the average rate of change over that interval is 2. We know this function is continuous and differentiable, so that tells us that it is true that at some point the derivative has to be equal to 2. So now that we've shown those two conditions, we can say, therefore, by the MVT, mean value theorem, and then I'm just going to use this question stem to form my conclusion. So I say, by the MVT, there is a time t in this interval at which C prime of t equals 2. So always use that question stem. That will often help you write your conclusion. So for this, they gave 1 point for calculating that average rate of change, and then 1 point for the justification, citing the MVT. All right, and then for us, the last part here wants to know, let's see, they're giving us a function to model the amount of coffee in the cup, And they're saying using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. So they want to know the rate that something is changing at a specific point in time. That means we need to find the derivative to get that instantaneous rate of change. So what we need is b prime of 5. Now for this year, since you guys have a calculator, you would definitely use your calculator to find this. I'm going to make a note here that we would use math 8 to type that into your calculator. So you would do math 8, type in that function at your value of 5, and let's see, you should get this approximate value. And our unit then, because this is a rate, would be ounces per minute. Now, as far as the scoring on that, the original question was no calculator, so they gave you a point for calculating, finding an expression for the derivative, and then one for plugging in. If this were a simple calculator question, you'd most likely get 1 point for that answer. So that's it for number 3.